नाउ वी आर डीलिंग विद ओपन सिस्टम। ओपन सिस्टम में सबसे पहला टर्म आता है एंथैल्पी का, H इज इक्वल टू यू प्लस पी वी। अगर एक फ्लोइंग फ्लूइड है जो किसी सिस्टम के अंदर आ रहा है और सिस्टम से बाहर एग्जिट हो रहा है, देयर इज़ अ फ्लो, तो वो जो फ्लूइड आ रहा है उसके अंदर दो एनर्जी है। जब वो एंटर हो रहा होगा उसके अंदर एक इंटरनल एनर्जी है और एक फ्लो वर्क है। एग्जिट हो रहा होगा तब भी एक उसके पास इंटरनल एनर्जी है और बाहर निकलने के लिए उसको एक फ्लो वर्क की ज़रूरत पड़ेगी। डोंट वरी अबाउट फ्लो वर्क एंड इंटरनल एनर्जी बिकॉज द टर्म H enthalpy takes care of both internal energy and enthalpy, sorry, flow work. Kilojoule Newton per meter square meter cube. This will take care of this. These are the units. अगर यहाँ स्पेसिफिक होगा तो यहाँ ये स्पेसिफिक वॉल्यूम होगा, ये भी स्पेसिफिक क्या होगी, इंटरनल एनर्जी। प्रेशर क्योंकि स्पेसिफिक होता नहीं है तो वॉल्यूम, ये वॉल्यूम होगा स्पेसिफिक वॉल्यूम। नाउ फ्लो वर्क्स ओनली कम्स इन इफेक्ट व्हेन ओपन सिस्टम आई, व्हेन मास एंटर्स एंड मास एग्जिस्ट or mass exit. Explaining full, suppose there is a fluid which is entering a system, okay. Flow work, pressure with which the fluid is flowing और वॉल्यूम फ्लो रेट ऑफ द फ्लूइड, वो यहाँ पर रखना तो उस इंटरनल एनर्जी मिल जाएगी उस फ्लोइंग फ्लूइड की। सपोज देयर इज़ अ फ्लोइंग फ्लूइड, सो उसकी जो एनर्जी होगी पहले होगी इंटरनल एनर्जी प्लस प्रेशर विथ विच इट इज़ फ्लोइंग एंड फ्लो रेट ऑफ द फ्लूइड। डोंट वरी, डिस्प्लेसमेंट वर्क इज 0 फॉर ओपन सिस्टम है, MS के क्वेश्चन। स्टेडी फ्लो डिवाइसेस, वो डिवाइसेस तो जिनके अंदर जितना मास एंटर होगा पर सेकंड, जितना मास एंटर होगा उतना ही पर सेकंड मास एग्जिट भी होगा। सपोज एक इनलेट है और एक आउटलेट है, तो जितना स्टेडी फ्लो के अंदर MI इज इक्वल टू M आउटलेट, और मास को लिखा जा सकता है ρ1 A1 V1, जनरल फॉर्मूला है ρ2 A2 B2। अब अगर कंप्रेसिबल है तो ρ1 और ρ2 अलग अलग होंगे, इसकी वजह से वेलोसिटी भी अलग अलग होगी। थर्मो में वैसे भी रो को हम कांस्टेंट मानना अच्छी बात नहीं। नाउ स्टेडी फ्लो मतलब मास जितना अंदर आएगा उतना बाहर जाना चाहिए। स्टेडी फ्लो में नो एक्यूमुलेशन इन द सिस्टम, मीन्स जितनी एनर्जी आई उतनी बाहर एग्जिट करनी चाहिए। सो EI इज इक्वल टू EF, MI इज इक्वल टू MF। Now the formula H1 plus half V1 square plus GZ1 plus Q to the control volume. Suppose what is this? Suppose there is a control volume in which there is one entry and there is one exit. For steady flow, amount of mass entering should be mass exit. Now, amount of energy entering the system are first the internal energy of this flowing fluid plus flow work of the flowing fluid which is represented by H1, both are represented by H1, plus half MI V1 square, the velocity with which it is entering, and MI GZ1 plus Q to the control volume, how much heat is be added to the control volume, H2 plus half V2 square plus GZ2 plus work to the control volume, work done on the control volume or work received by the control volume. This equation is energy balance, EI is equal to EF, means no accumulation of energy in the system. This is valid for energy balance, is universal law. It does not care about how the flow is entering or how the flow is leaving. Only up to certain case, if the flow is steady, then EI is equal to EF. The flow can be reversible, irreversible. So this equation is valid for open steady reversible and open steady irreversible. Now suppose this is the case and this is a steady flow, इसका मतलब क्या है, MI plus M2 is equal to M3 plus M4 case, and energy entering कौन सी होगी, इसका इंटरनल एनर्जी प्लस फ्लो वर्क, तो MI UI plus MI, सॉरी MI नहीं, P1 टोटल वॉल्यूम, मतलब स्पेसिफिक नहीं V1, क्योंकि हमने MI लिया ना, MI इंटू UI प्लस फुल वॉल्यूम प्लस हाफ MI V1 स्क्वायर प्लस m1gz1 प्लस सिमिलरली दिस फॉर दिस, तो ये हो जाएगा, क्या हो जाएगा, ये हो गया mi hi प्लस हाफ m स्क्वायर प्लस m2 प्लस दिस प्लस heat added to the control volume. This is the control volume which I study. So heat added to the control volume is equal to m3 into ये जो भी है प्लस m4 into जो भी है प्लस work received or work added to the control volume. Remember, m is equal to rho av. It's for air, real gas. It's m is equal to rho av, just mass is equal to density by volume, and I don't think there is any exception for this. But of course this equation is valid only for study, maybe reversible or irreversible. So why specific volume, why the term of pressure here, rho av represents millimeter cube per second. So millimeter cube per second is specific volume, not specific volume. It's not specific volume, it's volume flow rate. Specific volume is meter cube per kg. It's volume flow rate. Remember, because we are dealing with a flow, so there is going to be a flow rate. Here also it comes as what we are saying, meter cube. We will see that meter cube per second or meter cube, here it would come. But if there was specific, it will be meter cube per kg. Remember, sometimes specific volume of the fluid is given. Specific volume of the fluid is given. इसका मतलब by using PV is equal to MRT, we can find the density. Specific volume for any, like specific volume of water is given, means 1 upon specific volume density is given. Sometimes in the question pressure and temperature are given. These are given because so as to find the value of density or specific volume, as we can say. At entry, volume and temperature are given when there is a gas, just to identify the specific volume or density. Throttling valve. Throttle valve are throttling process is irreversible steady flow process. Throttling valves causes pressure drop without involvement of any work or heat. The throttle valve causes large drop in pressure and also causes temperature drop in accordance with Joule-Thomson coefficient. Temperature may drop for real gases, but for ideal gases temperature don't drop. Pressure is dropping, of course pressure is dropping. Flow in throttle valve is considered adiabatic because it is irreversible adiabatic. Irreversible adiabatic does not need insulation for Q is equal to 0. Irreversible adiabatic is very fast process, so time is not there for the heat to transfer, and work transfer is equal to 0 as throttle valve don't give any work. So first law of thermodynamics is valid because throttling is also a process, and Q is equal to W plus delta U has no exception. It is also valid. Q0 W0 means delta U is equal to 0. If it was an ideal gas, then T1 is equal to T2 means T1 is equal to T2 does not mean throttling is an isothermal process, because first of all it is an irreversible process, so in between points are not defined. So in between we don't know what was the temperature, but yes, of course the initial and final points are same, but in between it is not same. So we cannot say that it is isothermal, but definitely temperature at initial and final are same for ideal gas. For real gas, delta U is equal to 0 does not mean T1 is equal to T2, because U is function of pressure and temperature for a real gas. Okay. Now suppose in throttling, the SFE is valid still in throttling because SFE also has no exception. Only being steady is the exception, and throttling valve is a steady flow device. So consider C1 and C2 as equal because throttling does not interfere with the velocities. Suppose Z1 is equal to Z2. Suppose and of course there is no heat addition, no work done, so we get H1 is equal to H2, means delta H is equal to 0. Delta H is equal to 0. And one more important, in throttling process, the entropy of the system changes. Yes, we will see in power plant the entropy of the system changes. The entropy of surrounding is 0 because the process is irreversible adiabatic, and for irreversible adiabatic Q is equal to 0. Even for reversible adiabatic or irreversible adiabatic, Q is equal to 0. So there is no heat transfer to the surrounding, so delta S of surrounding is equal to 0 because entropy is defined as heat. So H1 is equal to H2. Delta H mcp dt is valid only for real gases undergone reversibly or irreversibly, both. A heat exchanger used to heat cold water at this, hot water at this, and consider the steady flow. Find the exact temperature of cold water. First, as these are not mixing, apply SFE for this. जितना मास आएगा उतना मास बाहर जाना चाहिए, और जितनी एनर्जी आई थी उतनी एनर्जी बाहर जानी चाहिए, मतलब SFE लगाओ क्योंकि स्टडी फ्लो है. स्टडी फ्लो SFE we apply. From here you will find that Q from the control volume is around 84,000. 84,000, 40,000 तो सराउंडिंग में गया, मीन्स लेफ्ट ओवर वाटर के पास गया होगा. ना अप्लाई द SFE फॉर वाटर, इट इज़ अ स्टडी फ्लो. तो वाटर की इनलेट एनर्जी H1 प्लस हाफ V1 स्क्वायर प्लस GZ1 प्लस हीट एडिशन टू द कंट्रोल वॉल्यूम. वाटर से कंट्रोल वॉल्यूम, उसमें यहाँ की जो हीट एडिशन है वो यहाँ पे गई. वर्क तो कुछ कर नहीं रहा हीट एक्सचेंजर. फ्रॉम देन यू विल गेट वैल्यू ऑफ H2. फ्रॉम H2, delta H is equal to mcp dt is not valid here for water, but for air it is valid. Suppose if this were to mixing, then m1 plus m2 is the exact mass flow rate. So still apply SFE. Individual first m1 h1 plus half m1 h1 plus m2 h2 plus q is equal to m3 h3 plus half m3 c3 square plus m3 c m3 g z3 plus work is equal to 0 because there's a heat exchanger. And remember m3 is equal to m1 plus m2. From here we know the equation SFE h1 plus this is valid for steady flow, reversible, irreversible, ideal gas, any fluid, anything. Just the condition be steady flow. Now the Euler and Bernoulli equation, from here we can see, first of all Euler is only valid for reversible flow. Reversible means ideal flow. It is only valid for ideal flow because somewhere we used PDV work, and it is only valid for ideal flow. Compressible or incompressible means a flow which is ideal, incompressible or compressible, you can use this equation. Steady, reversible, incompressible, or steady means ideal. Reversible means ideal flow. Steady होना चाहिए, steady, reversible and incompressible or compressible. But the Bernoulli equation is only valid for steady, reversible and that too incompressible. मीन्स गैस के लिए बर्नौली इक्वेशन नहीं लगी, गैस के लिए ये लगेगी, वो भी स्टेडी फ्लो में, और ये लगेगी सबके लिए. ओनली कंडीशन स्टेडी फ्लो.